Hi all, welcome to part 17 module 2 logic system design. So from part 14 onwards we were discussing about K-map, and based on the examples that we discussed in the previous lectures we are summarizing something. So before coming to this part I request all of you to start from part 14 at least. Okay, so K-map, some of the observations are like this. So far we've seen many examples of K-map. You know how to come up with the 2 variable K-map, 3 variable and 4 variable K-map. So now you can see that this is actually a rearrangement of the truth table, right? So that is the first observation we had. So truth table itself we are visualizing it in a different way, right? And you know it's introduced by the person called Maurice Karnoff in 1953. Okay, so you can keep this factual information in mind. Now K-map can do all the algebraic simplification. It's like you know how to minimize a given expression. So before K-map we were using the algebraic simplification procedure, right, where we apply the Boolean algebraic theorems as well as postulates. With the help of them we simplified the expression, and that procedure you know. So now we can do the same thing with the help of the K-map in a systematic way. So things are done, but in so what is the problem with the algebraic simplification? Different people will be applying simplification different ways. So the way I am using may be different from what you are trying, but finally we may reach simplified expression or not, that depends, but the procedure is different. But here we have a systematic way by which we will get the minimized Boolean expression, right? So we can call it as minimized Boolean expression. So in general this minimized Boolean expression can either be in the sum of product form or in the product of sum form. So accordingly we can call it as minimized SOP, sum of product, or minimized product of sum. So any one of the form we can reach. So what we've seen so far is how to come up with the minimized sum of product, and in this lecture we will see how to come up with the minimized product of sum expression also. Okay, now what we are doing is in the K-map we are actually grouping things, right? So we are the adjacent ones we are grouping to some cubes, cube like structure. So what is a cube in a K-map? So cube means that typical shape we are grouping is what we call as a cube. So it is actually a collection of some 2 power m cells. Okay, you could see that, and such that every cell is adjacent to m other cells. If you want, let me explain this point a little bit. So what is happening there is, see, suppose I am having uh, our 3 variable K-map. So what we done is like so these are all the cells we are having, right? So and let's say A, B and C, 0 0 0 1 1 0 1 1, sorry, 1 0 1 1, right? Gray code we are using, then 0 1, fine. Now you know this is like this is the cell 0 1, then this is 2, this is 3, cell number 4, cell number 5, cell number 6 and cell number 7. Now how we are grouping the cells? What we are doing is we will either group like some so even if I have an isolated min term I can group it like this, that is fine. Now if I have something like say 2 ones, what I can do, I can make a grouping like this, right? All the things are fine. So here I had tried to have a grouping, a cube containing just a single cell. So that is nothing but 2 power 0 cell. So here I am having a group containing say 2 power 1 cells. Okay. Now, so I just want to give you the other for 4 combination also. Let me draw a different one. Same thing only, 2 variable itself we can take, sorry, 3 variable itself we can take, or 4 variable, everywhere we can generalize this concept. Okay, fine, this is the same thing. Now you know you can have a grouping like 0 1 2 3, accordingly label the rows and columns, 4 5 6 7. Now based on so if I want a grouping like this I need that many ones, then only I can do like that. So suppose I am having something like this and this and this, so what I can do, I can do a group like this. You know, inside this I can have some 2 element group also. So but always we will try to get the group with the or the cube, so we can call it as a cube. So this is a 2 power 0 element cube. Okay, so here I am having a 2 power 1 element cube, something like this. So here I am having a 2 power 2 element cube, right? And you know, if all are 1 I can have a so something, let me take that example also. And so it's a very important concept. So if I am having drawing is a problem for me. is a 4 variable k map, something like 1 2 3 4 4 columns and 4 rows I'm having. So what I'm doing is let the variables be a b c d, then 0 0 0 1 1 0 1 1, right? See here also 0 0 0 1 1 0 1 1, like that gray code we will add. Then the cells are like 0 1 2 3, this is like 4 5 6 7, then again numbering will come here. So I'm just following the ordering only, because why I'm writing 8 here, because a b c d it is like 1 0 0 1 and 3 zeros, that is 8, a decimal of 8, right? 9. Similarly you can do for other cells also, 12 13 14 15. So this many cells are there. So now if I'm having something like this, the min terms are like min term 1 3, let's use a different color, min term which are active are like 1 3 5 7. I'm just taking an example. So now maybe some of the min terms are also there. So what we will do is we can directly have a group of 8 cells. So what is 8? Some 2 power 3 element cube I am having. So like that. So in general what we are having is 2 power some 2 power m cell cube I am having, right? Cell cubes. Now we saw example for all these 2 power m categories. So this is something we gone up to 4 variables, so we can generalize it to 5 variable also. So that is a different thing. Okay, fine. So now hope it is clear. Now tell me what is the definition. The requirement is like every cell within the cube should be adjacent to some m cells, something like that. So here you can see that when I am having this 2 power 1 collection cube, or this particular cell number 3 is adjacent to cell number 7, only one cell, right? So here it is not adjacent to anyone else because it is a 2 power 0 cube. Now if I am looking at a 2 power 2 cube, can you tell me how many cells this cell is adjacent? We can see that this if I am looking at this particular cell, I mean cell number 1, the adjacent cells of cell number 1, like that I am writing. So this is my cell number 1. So which are all the, or let me take that one, you may confuse. Cell number 3 you take. Okay, so how this cell number 3 is adjacent to what? It is adjacent to cell number 1 and cell number 7. Is that concept clear? Okay, because so what we are doing is when we are moving across this cell number 1 to 3, you can see that only variable is being eliminated. That is the idea behind this kind of a grouping. If you are having a group with some 2 power m cells, then only you can eliminate 1 or 2 variables accordingly. Okay, so similarly this is something a bare definition of what called a cube, but it is not something much important, but still I am reminding you this is how we done this grouping. So what are all the cells? This cell number 5 is adjacent. Cell number 5 is adjacent to cell number so it's actually adjacent to cell number according to this particular grouping, it is adjacent to cell number 1 and cell number 7. Okay, fine, like that. So that is a way, because it is sharing a common edge, like that you can initialize. So this is that they are defining, like every cell is adjacent to some 2 other cells. Similarly, if I am looking at this 2 power 3 element grouping, you can see that what about this particular cell, which are all the cell, this cell number 5 is adjacent. You can see that as per this grouping, cell number 5 is adjacent to cell number 1, cell number 7 and cell number 30, right? So like that. So don't take the diagonal element and all. So just they should share a common edge, like that you can visualize. So actually what is happening, when we are moving from 5 to 1, there is a chance that one variable will get eliminated. You can see that when across this 5 and 1, this b is eliminated, right? Similarly, across this 5 to 7 transition, the variable c is getting eliminated because c is changing from 0 to 1. And you know the reason, everything that we discussed in the last class. Similarly, from when I move across this 5 to 13, you can see that the variable a is eliminated. So like that, when we consider all these adjacent combination, you can see that whenever I am having, so this is very important what I am going to write now. So if I have a 2 power 3 cell cube, if I grouped some 8 cells together, you can see that after minimization, some 3 literals are being eliminated, or 3 variables and its combinations. 3 literals are eliminated, and I will get a simplified expression containing a single literal, because totally there are 4 variables, right? So 4 variable. So can you tell me what is this particular grouping corresponds to? I'm just taking, you can think of one anywhere. So this is special case. I'm just discussing this. You can see that when I'm moving across the rows, you can see that the variable B is eliminated and the variable A is eliminated, right? So you don't have to think about them. Similarly, when I'm moving across the rows, you can see that the variable C is eliminated. So what remains is with a value of 1 D. So the entire thing corresponds to, as it is 1, this entire grouping corresponds to D. So this is just D. And you can see that when I am looking at this kind of a grouping, okay, this is just D, you can see that 3 literals are eliminated. That in this particular example, which are eliminated, you can see that here A, B, C are eliminated, right? Eliminated, and the simplified term contains only single one variable. Right. So 3 literals are eliminated, means 4 minus 3 literals remains. So that is what is our intention. So we always need the largest grouping so that maximum literals are being eliminated in the simplified expression, and need an expression containing minimum number of terms as well as minimum number of literals in each term. So that is what is a simplified expression according to us, right? So that's all. So that you can implement it using a very simple circuit, Boolean circuit. Fine, that about it. So similarly here also. So this concept. So when you are grouping 2 cubes, you can see that how many variables are eliminated. So 2 literals or variables. Literal, when I am writing the term literal, it is variable or its negation. So that is a generalized term. Eliminated, and 2, so totally there are 3 variable accordingly. If there are 4 variable, then accordingly. So here 3 variables are there totally. So only 3 minus 2 literals remains in the final simplified expression. Hope everything is clear right now, and you can just think about what is this one corresponds to. So when I am moving, so 0 0 0 1 1 0 1 1, you can see that when 0 1. So when as far as A is concerned, it is eliminated when you are moving across the row. Now here the 0 to 1 change, this B is eliminated and C remains. So the entire thing corresponds to just C. Okay, so like that we are doing the grouping. But if I am having a smaller group, accordingly the number of, so here what is this means? See, I have a grouping of 2 power 0 cube. That means nothing is eliminated. 0 literal eliminated, right? 0 literal eliminated. So that how many literals are there totally? 3 minus 0 literals remains. So that means all literals remains, right? All literals remains means it is a min term. So we couldn't simplify it further. That is the meaning. So when I am having some 2 power m cells cube, you can see that some m literals will be eliminated by this. So using this m literals eliminated, you can just throw them away from the final simplified expression. And how many variables are there totally in the expression? Some n variables, then n minus m literals remains. Okay, so that is a general thing. Okay, that about it. So that's the concept of cube. That grouping is something, if you want the term you can use it, otherwise you can ignore it, fine. So now note 1, what happened when writing the product term from the K-map for any combination of min terms, the variables which keep changing are removed. So the variables which change are removed. Hope you understand the meaning. So what happened when we are grouping, the variable which is changing from 0 to 1 or 1 to 0 across row or column is removed. So that is the meaning of that line. So if I am writing everything, it will be complicated. Hope it is clear. It's whenever a variable is undergoing a change from 0 to 1, you can see it across row or column. That variable is eliminated because on the background that variable is in the pure and the complemented form, a plus a bar, and you know a plus a bar is 1. That is what is happening on the background. Okay, clear. Now in a K-map, second note is like this. We create cubes of size 2 power m so that we can write the product term for that particular cube, and for every cube we are writing the product term. And you can see that this is very important. The largest group corresponds to smallest product term. So always try to get the largest group containing all the ones. So that is our idea. So far what we are trying to get is the minimized sum of product expression. Now, how to get the minimized sum of product expression? You know it clearly, right? So, the first thing you have to keep in mind is making the larger group. Then only you will get the minimized expression. So, what do you mean by minimized sum of product or minimized product of sum? Whatever it is, the total number of terms. So, in case of sum of product, the terms are nothing but the product term. Okay. In case of product of sum, the terms are nothing but the sum terms. So, whatever it is, that individual term, whether it is product term or sum of term, reduce the number of terms as well as reduce number of literals within a term. So, both you have to take care. So, how can you reduce the number of terms? By reduce the number of grouping. Okay. So, try to get minimum number of grouping that cover all the ones. How can you reduce number of literals within a term? By making the largest grouping. Okay. So, both things are clear, right? So, reduce the number of grouping as well as reduce the number of literals within a group by making the group largest, right. So, always try to make the largest group as large as possible, covering only once. So, when it comes to minimum sum of product, you are supposed to group only once, keep that in mind. Okay. So, here we are talking about minimum sum of product, that is why only one. Don't group any 0. Okay. The vacant cells are nothing but that corresponds to 0. So, don't look at them. But when we are having product of sum, we will be grouping zeros. That is what we are going to see. Just apply the opposite thing, that's all. Now, focus on covering all ones of each term by minimum number of cubes and larger groups. So, both are important. So, total number of cubes you have to minimize, right. How many groupings or cubes are there, that you have to minimize, and focus on largest group usable, right. So, both will make your expression minimized. So, the number of terms we need minimum as well as within a term the number of literals we need minimum. How can you reduce the number of terms? By minimizing the, so I don't have to write it again, right. Hope it is clear. How can you reduce the number of terms? By minimizing the number of grouping or cubes. Now, how can you make each group containing minimum number of literals? By making the group size largest, right. Hope both are clear. Now, that is also in choosing adjacent squares in a map, we must ensure that all the min terms. So, that is something again you have to keep in mind. You should not leave any one without which is not part of any grouping. So, you have to ensure that all the ones in the particular K map should be covered by any of this grouping cubes. So, no one should be left out, right. So, the number of terms in the expression should be minimized. In other ways, how we can achieve it? By minimizing. So, the final simplified Boolean expression, if you want to reduce the number of terms, so we can achieve it by reducing number of cubes or groupings. And also within a group cube you can have a maximum number of ones, so that you will get the minimized expressions, and those things were already there, and there should not be any redundant terms. This is something you can make, some of you may make this mistake, like so when you are grouping, you may group it one way, and within a group some overlapped group you can have. Overlapping is fine, but at least one extra new one should be covered by that overlap, otherwise it is just redundant. So, what we covered already, we are trying to group again, that is just a waste of work. That will result into something like, if you are some redundancy is there, x plus x is equivalent to x. So, this you try to eliminate when you are having the grouping. So, don't try to group something or its subset again, right. So, don't try to have any redundant terms. So, we will see this more in subsequent explanation. So far we done in a very smart way, right. Whenever we are having a group, so far there were no redundancy, right, but sometimes maybe by practice only I can correct that thing from your side. Okay. So, I want to see somebody is making that redundant grouping, then I can tell you like this is not something the way you are supposed to do. So, that we will do. Fine. Anyway, now the next topic is like a product of sum minimization. Actually, mainly you have to focus on the minimum sum of product minimization only. So, once that is clear, this is something you can do easily. That is the first thing. And exam point of view also, 90% questions will be coming from sum of product minimization, because that is the default one. and some 10% you can expect question from product of sum minimization also. That is why this is something added extra. So I will just tell you. So the thing is that don't confuse what I am going to tell with the what we discussed so far. What we discussed so far you keep in your mind and let it be stable in your mind. Okay, now just understand this concept by comparing with what you learned already. Okay, so that is the best way. If you are understanding it something different from what we discussed so far, you may be confused. That is why I am repeatedly telling you that. Okay, so just try to compare in your mind what we learned so far and accordingly try to understand this. So here we have an expression. So this is my expression containing 4 variables. See, A, B, C, D. 4 variables are there and it is containing 0, 1. Some min terms are given. And you are supposed to find out the product of sum minimization. And you know, this is how the solution is given. I am going to tell you how to obtain this. This expression corresponds to the simplified product of sum expression, that is A dash B dash into, because why it is called the product of sum? This is a sum term, right? This is a sum term and this is another sum term, right? And the sum terms are finally multiplied together. So that is the final solution, and we are going to see how to reach this. That is our target. So I have a 4 variable function 0, 1, 2. Let me remember till that. So instead of, because my drawing skill is not good, I thought of giving you a template. Inside this template I will fill the things. Okay, f of a, b, c, d is given like a sigma. 0 is there, 1 is there, 2 is there, next it was 5, I remember, 0, 1, 2, 5, 8, 9, 10. Sometimes I may write this differently and you will get the different solution, like that it happened previously, right? So okay, so the variables like A, B, C, D, you know, you can label them in any order. So this is the one the template we studied, that is why I am writing like that. But if you are writing differently, accordingly name the cells properly. So that is the thing you have to keep in mind. Fine. 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1, right? Let me name the cells, then it is very easy for me, that is why. Otherwise you can do in any way. 0, 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now, which are all the elements that are present in the expression? 0 is 1, 1 is 1, I mean these min terms are there, then min term 2 is there, min term 5 is there, min term 8 is there, min term 9 is there and min term 10 is there. Now you have to group them. So that is your target. So now you know it very clearly. Yeah, there is a twist in this question. You know how to find out the minimum sum of product expression for this, right? You will make the so what I can tell you now is, okay, I don't have to confuse you, because how to find out the minimum, so that I will just explain, then I will go back. Okay, minimum sum of product expression is something we discussed already. What we will do, we will make the largest group out of this one. How can you group them? You know, the corner grouping, hope you remember, this one, this one, this one and this one. This will make own group, right? Now what else? These two ones remains, right? So you can group them like this 2 1 and this 2 1 by folding. All those things hope you remember. Now this one again remains. There is no other way. This is the one grouping possible. And corresponding to this 3, so 3 terms will be coming in the expression. Write the product term and that will give you the final simplified one. But I am not discussing this right now. This is something I just given you in such a way that your memory is refreshed, right? Let's keep that one there. Okay, fine. So what we need is the minimum product of some expression. So if you want sum of product, what you done is you grouped once. Now if you want, just compare. Okay, keep only sum of product minimization in your mind, and this is just you just understand only the difference, how to do this, that's all. So to get the minimum sum of product expression, you are supposed to group. So here you have to group what? Group the max term, group max terms. So max terms corresponds to zeros in the truth table, hope you remember, or zeros in the K-map, because K-map is just a visualization of the truth table only, right? So the empty cells are actually zeros. So far we were just ignoring the empty cells, because empty cells we are not interested, right? Now we are interested on the empty cells only, because we need the minimum product of some expression. Okay, so now just ignore the ones. So anyway, I am writing it here. In exam point of view, you just focus on the zeros. If you are confused, don't write the one. Okay, that is my request. Okay, now focus on the zeros and try to get the largest grouping out of the zeros. Okay, let me just verify. 0 is there, 1 is there, then 2 is there, 5 is there, 8 is there, 9 is there, 10 is there. You know, this is the sum of product expression. This is the canonical, right? Canonical SOP. That is why corresponding to each term, I 0, 1, 2, 3 everywhere I assume that these are all the product term or the min terms. I put a 1 there. And you want, and you know, in the truth table the remaining, so these are all the entries where I have a 1, and the remaining entries are what? Zeros, right? And I need finally the minimum sum of product expression. So that is why minimized product of some expression. That is why I am going to group the zeros. So how can I make largest grouping of zeros? So what you can do is, you can see this is one grouping possible. So here, is it fine? 4 zeros. Can I get a group of 8 zeros? No, right? You can't get. Fine. Now these 2 zeros are there, right? What I can do is, yeah, one thing I can do is like these 4 zeros I can group. This is another grouping possible. Now again 2 zeros remain. So what I can do is, these 2 0, or can I use different color so that it is. So let me tell you what is the term corresponding to this when I am having a grouping like this. What is the term corresponding to, you know, when I am moving across the columns, you can see the labeling. It's both C and D are changing from 0 to 1 in adjacent cells, right? So what remains is this A and B, and both are in C. Now A and B are 1 1, right? In product of some in minimum SOP, what you are doing is, you will look at this, you will be writing it like a AB. Hope you remember, because if it is 1, I will write like a. If it is 0, I will write like a bar. That is what we done here, there. But in minimum product of some expression, what I need is the sum term. Sum term means in between plus should come. And also when we are writing sum term, hope you remember, when I have 1, I used to take it as a complement. Hope you remember, right? So this is a corresponding one, and you know, it is just like what is the corresponding minimum sum of product term? This is something already in your mind, right? Actually when you complement it, you will get it as A bar plus B bar. So that is your equivalent sum term. So sum term and product term are, so let it be there. Hope you remember this. This is something, because the ith min term or equivalently the sum term. So if I am calling it as min term, I need all the variable, that's all. Is actually equal to something like the ith max term, capital M, its complement, something like that. All those things we seen already. So min term and max term are just complements of each other. So if somebody is asking you what is the min term of this, it is something like a dash b dash, but actually it is wrong, because something like a b, because I need ones there, but as I am grouping the zeros, I am supposed to write the max term for it. Not max term, sum term. Okay, if I am calling it as max term, all the variables I am supposed to have, like A, B, C, D. But anyway, here only 2 variables are there. C and D, what happened? They are eliminated actually, because I am having a 2 per 2 element grouping. So 2 elements are eliminated, 2 variables are eliminated. That C and D are eliminated, only A and B remains. And how to write the corresponding term? It is just to do the complementation of what we done in minimum SOP. What we done in minimum SOP, we taken the term, and A, one you take as A, one you take as B, like that. So take the opposite thing, A dash plus B dash. Hope it is clear, right? So it is just the complement of what we done previously. Now let's see the next grouping. Now it will be more clear. So the next grouping is like vertically I can group these 4 ones. So the next question is, can I make a bigger grouping of 4 ones, 4 zeros? It's not possible, right? So what is this? This corresponds to, you know, when you move across the rows, the A and B get eliminated. 2 variables are eliminated. So what remains is C and D. Again, the C and D are 1. So it is just like a C plus D, C dash plus D dash. So this is the corresponding sum term for this grouping. Now I need one more grouping. Let me use a different color. What color? Yeah, will it look good? So what I'm going to do is, yeah, this is fine. I'm having a grouping of but it is not visible, right? Fine. I'm going to have a grouping of, I mean actually this 0 and this 0 remains, and I'm trying to get the largest grouping out of these two. I can fold them and I can make a 2 power 2 element group, so that two variables will be eliminated. That is the benefit I am having, right? Now tell me what is this whole thing corresponds to. This whole thing corresponds to definitely two variables will be eliminated, and which are they? A is eliminated because A is changing from 0 to 1. A is eliminated, so what remains is B. So B dash, like that you have to write, right? So B dash. Now similarly from first column to last column, this C is getting eliminated, so what remains is D, and D is 0, that means D as it is. Okay, I'm removing all those extra things. See, when I'm moving across the rows, you know that A is eliminated and what remains is B, and it is 1 means B dash, plus when I am moving from first column to last column, C is eliminated and what remains is D, and it is 0 means D as it is. Yes, that's all. So this is our, so any 0 left, right? We covered all the 0 with maximum size grouping possible. So this is our final answer. So the final answer, the final minimal sum of product expression we are interested is what? Is equivalent to the first term is like A dash plus B dash into the second term was like C dash plus D dash into B dash plus D. Let's verify whether it is the correct answer. A dash plus B dash, it was given here, right? It's the first term, right? Correct. C dash plus D dash, yes. B dash plus D, right? Here you can observe something. You are getting a unique minimized expression, so particularly minimum product of sum. But and similarly sometimes you will get unique sum of product. Why I am stressing the term unique? Sometimes you know the simplified expression itself may be different for two people, okay, based on how they are grouping. So that is something that can lead to some confusion, but we will make it clear with our subsequent discussion. So is it clear so far? Product of sum minimization, fine. So what are all the questions we done before with the where we grouped all the ones? Try the same question with the try to get the minimum product of sum for all the previous questions we discussed. Okay, so let me give you the give it as an assignment. I am not going to take all of them before. I hope you remember many problems we discussed, but as it is less important, I taken on only one example. Don't think like that, it is important only. Okay, so what are all the problems we discussed so far? Find out the minimum product of sum. So just ones are there, so focus on the zeros and group the zeros and write like this, that's all. It's so easy, right? So just compare with the method what we discussed so far, so that it will be very clear for you. I am not going to take more example. Maybe in the subsequent discussion we will see more example. Okay, but anyway, hope it is clear. With this example, I am winding up the concept of product of sum. Still, if you have any doubt, you can ask me. You can comment in the Moodle or YouTube, wherever it is. I may take a separate video where we will see more examples. Okay, still if you are confused. Otherwise, let's proceed. Yeah, thanks for watching.